All right, so here is a tutorial on 11.5, which is using the ideal gas law, doing gas stoichiometry when you do not have STP conditions. So remember, at STP conditions, we were able to use this shortcut. We were able to go right from 1 mole of any substance to 22.4 liters. But that only works when you have those specific conditions. So when you don't, we need to use the ideal gas law along with stoichiometry. So here we go with example 1. So it's asking us for how many grams of Na3N. That's going to be our ending point. Another thing I want to start doing is identifying in the chemical equation which substances the question talks about. So I have Na3N. It says how many grams is needed to decompose, 36 liters of N2 gas. So there's my other substance. So those are the only two things I care about in the equation. Since I am not at STP conditions, I'm going to go back and use my ideal gas law variables to figure out what's what. Another thing that's going to be really important is recognizing that the ideal gas law variables have to do with the gas N2. Where that's going to be really important is right here. The moles in the ideal gas law have to be moles of N2. So let's start filling in everything else. We have a pressure of 1.15 atmospheres, a volume of 36 liters. R is still the same R because we're using the same units. And then we have our temperature of 299 Kelvin. Okay, so looking at this, I have enough information to solve the ideal gas law for the number of moles. All right, so that's going to be my first step on this one. So that's how you start these, is you look at start listing your variables, and then you need to recognize, okay, do I have enough information to use the ideal gas law or not? In this case, we do. So I've got the ideal gas law. Excuse me. PV equals nRT. Oops, that should be 1.15. And then a volume of 36 liters. I don't know N, I know R, and I know T. So I solve this for N. N is going to be 1.7 moles. Again, this is when it's really important, N2, because the common mistake students make is they see, oh, well, I'm trying to get to grams of Na3N, so the moles I get from this have to be moles of Na3N. But no, this mole value is coming from the ideal gas law. The ideal gas law is talking about a gas. So it is talking about N2. So then now my second thing I have to do is I need to convert the moles of N2 into, sorry, I meant to go to red there. I'm sorry, I meant to go to black, into grams of Na3N. All right, this is where the chemical equation is going to come in. So 1.7 moles of N2. And then from the chemical equation, we know that for every 1 mole of N2, it's equivalent to 2 moles of Na3N. And then 1 mole of Na3N. The next step is to use the molar mass to get it from moles to grams. When I look up or calculate Na3N molar mass, it is 82.98 grams of Na3N for a final mass of 280 grams. And you might be looking at your calculator and saying, wait, no, it's 282. The calculator is going to say 282, but right here I'm dealing with 2 sig figs because the volume was 2 sig figs. So I have 280 grams of Na3N. All right, so that's one way you might see the problem if you're ending in grams. That's the order you're going to do things. Example 2, we are similar type of problem, except that this one says what volume of F2 gas. So now this is my ending point. And again, to keep track of what is important out of my equation, I'm going to circle that. Measured at, we've got a pressure value and a temperature value, needed to produce 10.6 grams of NaF. So that's the other part of the equation that's important. So again, I'm going to start with my ideal gas law. Oops. And again, the ideal gas law, this is talking about F2. All right, so pressure, I know that. I know the volume I don't know, but that's my ending point, so I'm going to leave that blank. N, I don't know at this point, but I will need to calculate that soon, but we'll come back to that. R, of course, I know. Temperature, I know as well. Okay, so now I don't have enough information to solve the ideal gas law. So in the end, I'm going to find volume because that's what it wants me to end with. So I'm going to just label that as a V. What that means is I have the information I need to find moles and put that in the ideal gas law. And again, it's really important you recognize this is moles of F2. All right, because the information the problem gives me is 10.6 grams of NaF. All right, so to get to moles of F2, this is where I do my stoichiometry. So I need to first convert that into moles. So 41.99 grams of NaF is equivalent to 1 mole of NaF. All right, then I can use my relationship from the equation. I don't know why that just changed color. That was weird. All right, for every 2 moles of NaF, 1 mole of F2. And then I get my answer, which is for the number of moles of F2, 0.126 moles of F2. All right, the reason I did that was so I could put that in the ideal gas law. So that goes in. Then now I can solve the ideal gas law for volume. So pressure 1.10, we've got a volume, we've got 0.126 moles, we have our R value, and we have our temperature. So volume, you can do that calculation and end up with a volume of 290 liters. Again, this time we've got 3 sig figs because everything we're working with, pressure, R, temperature, grams, we started with, those all have 3 sig figs. All right, so then, so that's how you do those. The 2 different types you're going to see. Either we're going to give you the gram of the solid and ask you for the volume of the gas, or we are going to, we did in the first one, was we gave you the volume of the gas and we asked for the grams of the solid. Those are the kind of the 2 beginning and ending points. So with example 3, I want you to take a look at example 3 and then try that on your own. Stop the video and then pick up the video again to see the answer. All right, so this is example 3. So should have gotten 2.91 grams for this one. Again, we are starting, we know the volume. We know the pressure, which means the first thing that we're solving for is going to be the moles of F2 from the ideal gas law, which is this 0.0623 moles of F2. Then we always take the answer from the first calculation we do and we use it in the second calculation. In this case, it's to start the stoichiometry. All right, and that is how you do gas stoichiometry problems when you are not at STP.